There's a berry that survives minus 40 degrees Celsius. A shrub so hardy it was planted across North America specifically to stop erosion and reclaim land where nothing else would grow. A fruit that contains up to 400 milligrams of vitamin C per 100 grams, 7 times more than strawberries. And today, agricultural departments and invasive species councils have flagged it as potentially invasive. They warn you not to plant it near natural areas. They describe it forming impenetrable thickets. They have created guidelines specifically to control its spread. Plant nurseries sold it for decades as the solution to impossible landscapes. Conservation agencies promoted it for shelter belts and soil stabilization. And now some of those same agencies list it among plants of concern. This shrub thrives in salt, drought, and frozen wasteland. It fixes its own nitrogen. It requires no fertilizer. It produces berries loaded with rare fatty acids that most plants cannot make. And that resilience, that refusal to need perfect conditions, is exactly why it became a problem. This is the story of the superfruit we planted and then feared. Welcome to Buried Nature Archive. If this video already has you questioning what else we've been told about the plants around us, hit like and subscribe. We are documenting the crops that fed civilizations before industrial agriculture decided what belongs on your plate. Let us continue. Its scientific name is Hippophae rhamnoides. The common name is sea buckthorn. Hippophae comes from ancient Greek meaning shiny horse. The story goes that horses fed on the leaves gained weight and their coats became glossy. Whether that tale is myth or observation, sea buckthorn has been tied to animal and human health for centuries. Across Eurasia, from the coasts of Europe to the mountains of Central Asia, this plant has been harvested for food and medicine. It was not a novelty, it was foundational. Traditional systems used the berries for nutrition, the oils for healing, and the plant itself for land restoration. For hundreds of years, people understood that this shrub offered something rare. In the early 20th century, North America began importing sea buckthorn. The first recorded introduction was in 1923. The reason was simple. The continent needed plants that could survive where others failed. Sea buckthorn checked every box. It was cold hardy, it was drought tolerant, it was salt tolerant, it was nitrogen fixing. It was planted for erosion control, for shelter belts, and for land reclamation projects. It was the miracle shrub, and it worked exactly as promised. Sea buckthorn is a deciduous shrub, sometimes growing into a small tree. It has narrow, silvery green leaves and long thorns. The berries are bright orange, clustered tightly along the branches, and they persist through winter. The plant is dioecious, which means there are separate male and female plants. You need both to get fruit. The males produce pollen, the females produce berries. In an orchard, you plant roughly 1 male for every 6 to 12 females. The plant spreads through root suckers. One plant can become a thicket. That sucker lability is why it stabilizes soil so effectively. It is also why some people now call it invasive. Let's talk about what makes sea buckthorn an ancestral survival technology and not just another ornamental shrub. First, nitrogen fixation. Sea buckthorn forms a symbiotic relationship with a bacterium called Frankia. This bacterium lives in nodules on the roots and pulls nitrogen from the air, converting it into a form the plant can use. That means sea buckthorn does not need nitrogen fertilizer. It makes its own. Better yet, it enriches the soil around it. Other plants benefit. This is why it was used for land reclamation. You plant sea buckthorn on degraded soil and it begins the process of restoration. Second, cold hardiness. Sea buckthorn can survive temperatures down to minus 40 degrees Celsius or even minus 43 degrees, depending on the variety. Most fruit crops cannot handle that. Apples, peaches, and cherries all have limits. Sea buckthorn laughs at winter. Third, salt tolerance. Coastal areas, roadsides treated with de-icing salt, and saline soils are places sea buckthorn grows. Most agricultural crops would die. Sea buckthorn thrives. Fourth, drought tolerance. Once established, sea buckthorn needs very little water. It has deep roots. It survives dry summers that would kill conventional orchard crops. Fifth, it grows on marginal land. Poor soils, rocky slopes, sandy dunes, places you cannot grow wheat or corn or soybeans. Sea buckthorn doesn't care. It establishes, it spreads, it produces. The traits that make it a climate-resilient ancestral crop, suckering, thickening, and thriving on poor soils, are the same traits that get a plant labeled invasive. When a plant succeeds without help, when it spreads without permission, when it does not stay in the box you planted it in, the system calls it a problem. Now, let's talk about what is inside these berries, because this is where the suppression narrative starts to crack. Sea buckthorn berries contain approximately 400 milligrams of vitamin C per 100 grams. Compare that to strawberries at 59 milligrams per 100 grams. Compare it to raw tomatoes at 14 milligrams per 100 grams. Even when processed into juice, losses are relatively modest, around 5 to 11% of total ascorbic acid. Concentrate production loses more, roughly 50%, but even then, the remaining content is competitive with the best-known vitamin C sources. But vitamin C is just the beginning. Sea buckthorn produces two distinct oils. The seed oil is rich in linoleic acid, an omega-6 fatty acid, and alpha-linolenic acid, an omega-3 fatty acid. That omega-3 content is rare in berries. Most berries are sugar and anthocyanins. The pulp oil is even stranger. It contains high levels of palmitoleic acid, an omega-7 fatty acid. Studies report palmitoleic acid making up 32 to 42% of the pulp oil. Omega-7 is uncommon in the plant kingdom. It shows up in macadamia nuts and some fish. Sea buckthorn produces it in significant amounts. The seed oil and pulp oil have completely different fatty acid profiles. The seed is omega-3 and omega-6. The pulp is omega-7. That means sea buckthorn is not one functional food. It's two, depending on which part you extract. Oil content varies. Seeds can contain up to 12.5% oil by weight. Pulp is reported at 8 to 12% oil. For a berry, that's extraordinary. Most fruits are water and carbohydrates. Sea buckthorn is oil and vitamin C wrapped in a tart skin.
The plant adapts its chemistry to the environment. A berry grown on a coastal dune will differ from one grown on a mountain slope, but the core nutritional architecture remains. High vitamin C, high oil content, rare fatty acids. So here's the question that reveals everything. If this shrub is cold-hardy, drought-tolerant, salt-tolerant, nitrogen-fixing, and produces berries with exceptional nutrition, why is it on invasive species watch lists and absent from grocery store shelves? The answer has two parts. One is biological, one is economic. Both are disqualifying in a system that demands control and ease. First, the biological problem. Sea buckthorn does exactly what it was designed to do. It colonizes harsh environments. It spreads via root suckers. It forms dense thickets. In nutrient-poor systems like sand dunes, it can outcompete native vegetation. On prairies and in riparian zones, it can crowd out other species. The Canadian Coalition for Invasive Plant Regulation includes sea buckthorn among invasive plants of note. Flora of North America describes it as potentially invasive. Oregon State Landscape Resources warned that it has become a concern in the British Isles and in the Canadian prairies because it forms thickets that shade out competitors. This is institutional whiplash. The same plant once promoted for erosion control is now a species of concern in certain contexts. The traits that made it useful, aggressive growth, suckering, tolerance of poor soils, are the same traits that make it a threat in the wrong location. It is not that the science was wrong, it is that the plant did its job too well. When a plant succeeds beyond the boundaries you set, when it does not stay confined to the shelter belt or the reclamation project, the system reclassifies it. Second, the economic problem. Agricultural extension agencies in Manitoba estimate that harvesting sea buckthorn requires approximately 600 hours per acre. 600 hours. Compare that to mechanized grain harvest, which can be done in a fraction of the time. The berries grow tight against thorny branches. They are soft and easily damaged. Hand-picking is slow, painful, and labor-intensive. Mechanical harvest has been attempted with limited success. Some growers freeze the branches and shake the berries loose. Others cut whole branches and process them. But every method has trade-offs. Fruit quality suffers, labor costs soar. Yields are reported around 4 to 5 metric tons per hectare, roughly 1.8 to 2.2 tons per acre. That is respectable, but if you cannot harvest it economically, yield does not matter. Then there's the complexity of orchard management. Because sea buckthorn is dioecious, you must manage male and female ratios carefully. Extension guidelines recommend 1 male for every 6 females, or 7 to 12% of your planting as pollinators. Get the ratio wrong and fruit set suffers. Pruning is difficult because of the thorns. The modern food system is not built for crops like this. It is built for uniformity, mechanization, and ease of processing. Sea buckthorn requires hand labor, careful timing, and tolerance for thorns. That does not fit the industrial model. So instead of becoming a staple, sea buckthorn became a niche, a specialty crop, a functional food ingredient. It is sold as frozen berries, juice, concentrate, and oil. It shows up in cosmetics and supplements, but it never made the jump to mainstream agriculture. Despite the challenges, sea buckthorn persists. In the Great Plains and prairie regions, it remains a valued shelter belt and conservation planting. North Dakota extension materials describe it as hardy and suitable for windbreaks and erosion control. It is approved for conservation use and is planted intentionally in Canada. Manitoba and other provinces have developed specialty crop profiles for sea buckthorn. They treat it as a functional food with commercial potential, and they provide growers with production guidelines, pest management strategies, and market information. The knowledge did not disappear. It adapted. Small-scale growers and foragers harvest sea buckthorn where it naturalizes. Frozen berries are sold at farmers markets. Juice and syrup are made in small batches. Seed and pulp oils are pressed for specialty markets. The plant continues to do what it has always done. It grows where others struggle. It produces nutrition in climates most crops cannot handle. It survives. If you are watching this and thinking about growing sea buckthorn, you need to understand the context. This is not a plant you throw in the ground and forget. Check local invasive species guidance first. In some regions, especially near sensitive dunes, wetlands, or native prairies, planting sea buckthorn is discouraged. The risk of thicket formation and competition with native species is real. If you are in a controlled setting, an orchard, a hedge, a managed landscape, the risks are lower, but you still need to manage suckers. You still need to prevent spread beyond your boundaries. If you want to eat sea buckthorn, the easiest entry point is frozen berries. They work in smoothies. They are tart, almost astringent, but the vitamin C content is undeniable. Juice is another option, though processing reduces vitamin C somewhat. Understand the difference between seed oil and pulp oil. They have different fatty acid profiles and different uses. Seed oil is omega-3 and omega-6. Pulp oil is omega-7. If you are buying oil, know which one you are getting and why. Sea buckthorn exists in a gray zone. Too difficult for industrial agriculture, too aggressive for some conservation contexts, and too useful to completely abandon. It is a plant the modern system does not know how to categorize, and so it lingers, planted in some places, warned against in others, harvested by those willing to work for it, ignored by those who are not. They planted it, it worked, now it's on watch lists, not because it failed, but because it succeeded beyond the box they built for it. Every person who learns that the thorny shrub on the roadside produces more vitamin C than strawberries becomes harder to ignore. Every forager who harvests those bright orange berries in -40-degree winter is proof that resilience without permission still exists. If you want to learn about the other crops that sustained ancestors through ice ages, droughts, and famines, crops the modern system either forgot or reclassified as weeds, give the video a like and subscribe to Buried Nature Archive. Every video documents a plant that produced nutrition when everything else failed. Hit the bell so you don't miss the next one. And if this changed how you see the thorny shrubs along the highway, share it. The knowledge only survives if we pass it on. The next buried archive is coming soon.